Air Commander S. Kulkarni, AOC 13 BRD, Air Commander S.K. Chaudhary, Air Commander Yogesh Handa, Group Captain N.S. Pindra, Commodore Asim Anand, Captain A.K. Chakravarti, Captain Sujit Bakshi, Captain Shirish Dubey. I welcome you all, sir. It's the end users after all. The direction of research and development has to be directed from the frontal needs and challenges faced by the armed forces to innovate, invent and improvise upon. The basics of defense and warfare after all remain the same with the changing variables in the form of tools and technologies. I would like to invite Army Major S. Bhattacharya to make his presentation sharing the perspectives of the Indian Army pertaining to the future direction of research and innovation as to how Indian Army sees the direction moving forward. Major S. Bhattacharya, please.
Good morning, ladies and gentlemen. It's a privilege to be here today. I am Major General Bhattacharya. I represent the Army as a user in defense research. I look after the maintenance, repair and overall laying down policies, basically sustainment of Army's equipment related to missiles, guns, radio sets, electronic equipment basically. What I'll do is in the next 15 minutes or so, I'll cover the areas where the academics, the research institutions can participate in the Army's various ongoing programs and what are the facilities in the Army with which you can interface with. That will be my focus. I am going to cover 4 issues where we seek the researchers to come and work with us for their various weapon systems. The first is indigenization and self-reliance. The second is development of military simulators. The third is product improvement. And the fourth is involvement in weapon system development. Now coming to the first one, which is indigenization and self-reliance. All of us know here that the research spending in India on the defense research as a whole is just about 1%, less than 1%, out of which only 23% is spent by industry. Now if you have to move forward, like today's keynote address said very clearly, that this has got to change. And Army, being the biggest user of defense technologies, is one of the areas which one could look at. We have in the Army the Directorate of Indigenization, which is about 300 people strong. They have design and specification wings in 4 cities dealing with the various disciplines: armament, engineering equipment, electronics. And what they are seeking to do for the last few years is they take up small components, sub-assemblies of major weapon systems and then try to reverse engineer it or indigenize it. Especially focus being on the old Soviet and Russian legacy systems. Now here we are already interacting with some institutes, basically with the MSMEs, SMEs and their defense PSUs. We also have in-house our Army base workshops, which are basically factories for overall, depots basically for overall of major equipment. So all of these got together are focusing towards indigenization, and this is one major area and thrust area for us in the future. Now having said this, indigenization for us in the Army means it's actually based on 2 parts. The first part is that when a weapon system is being developed indigenously, that's our involvement comes into it. One of the examples, good examples, is the national project, Project Dhanush, that is the making of that 155mm gun. I think it's a wonderful job being done by the GCF, and there our inputs are taken. We have a project management team which takes in these inputs from the sustainers, which is us, because we are the users, we are the repairers of the equipment, maintainers of the equipment, and that synergy has worked wonders for this project so far. This is just one of the examples I can give on indigenization. We want to move ahead in indigenization from small components and sub-assemblies into major assemblies and maybe looking at the weapon system totally. But that's some time away and we are yet to find our steps in that direction. The second aspect, important aspect we deal in in where defense research is concerned is in development of military simulators. As all of you know, weapon systems are costly, their ammunition is even costlier. And there is a limit to which we can expend this ammunition. There's a problem of ranges. And training so many people on equipment, such equipment also causes a lot of wear and tear. So for this we have the Simulator Development Division, established about 15 years ago, 20 years ago in Secunderabad, who are interfacing very closely with the IITs and also with industry, DPSUs, to develop military simulators. Some of the success stories are development of the driving simulators, gunnery simulators for tank T-72 and the BMP. They have also taken other steps in certain area of augmented reality, but those I would say are baby steps. And this needs to be nurtured. And this is one of the major areas where we seek active cooperation of technology. Like today, it was described very well about this continuum of knowledge, technology and product. And if product has to be the final thing for which all this research and everything is being done, then this product has to have the mainstay. By which I mean that all the research that is going on must include some elements of the user in one form or the other, and one of these areas is the military simulators. This is a very big area for us now. The third is product improvement, and this again includes reverse engineering. Now we have bought many weapon systems, mostly foreign. The OEMs, some of them have gone away, they're no longer in production. Also connected with this is, as our operational requirements change, we need to exploit this expensive weapon system to do more and more. The performance has to be enhanced. They have to be modernized. Performance enhancement basically, and that is what we call product improvement. This is an area in which we are doing internally as much as we can do through various, we have a technology board, their projects are now with the IITs basically and some of the NITs, DPSUs. But this is a domain which will constantly find areas of development. Now, the spectrum of development in this domain of product improvement is vast. We can start with small PCBs, the logic of that, algorithms, going on to the complete engines and transmissions and whatnot. Now, this is where we also would look at involvement of academics, and the DRDO of course is already with us on this issue. My last issue is on involvement in weapon system development. Now this is something which we are discussing with the DRDO, with the DPSUs also, that when they take up a weapon system development, as simple or as complex as the Akash air defense system, the involvement of the user is very important. In the form of the project management teams which are there, we also seeking that the engineering issues are brought to the fore, because in the system design, the exploitation part of it and the experience gained from exploitation of similar weapon systems comes into use. So in this area also, there is a lot of scope of ergonomic system design, etc., where the involvement of academics and everybody can be done. Basically what we are looking at is self-reliance now. When we get a TOT or MTOT, the problem happens, the critical technologies don't come to us. One of the very small examples or important examples is the army depends a lot on night vision equipment, mounted on tanks or not mounted, mounted with the infantry weapon systems. And here there is a small component called the DDC, they call it, the Dewar Detector Cooler, which is the sensor. Now this, to repair it or to get it, we have to go back to the OEMs, costing millions of dollars in repair contracts. Now this is where the Bharat Electronics is working on it, others are working on it. But these are the small kind of technologies which we can offer to the academics, the research institutions, the research, the research institutes which are being set up, centers which are being set up in the IITs and ITs and other private institutes. These are some of the small technologies which can be taken up and improved upon. Now the point also is coming up is that defense has been driving research all over the world. We have seen this happen in the US. The internet today, as we see it, is a culmination of what was started a long time ago with ARPANET and DARPANET. So therefore, the defense research is actually the cutting edge of research and technology in the nation today, as has been brought out very well in this morning session. And this is where collectively we can do a lot. Today what is happening is there's a lot of disjointed effort. There's tremendous effort being done by the DRDO, and we know the maximum spending is done by the DRDO. They are integrating with other institutions, maybe the top institutions only. But today what was spoken about, setting up of centers of excellence, and the felicitations which was done to some of the private institutes was very heartwarming, because that is where we seek the maximum research areas to come up. If one goes and sees some of the DPSUs, the research centers which have been established, it is very encouraging. Because the young boys and girls, when you ask them that what are you doing, he said, well, somebody will say, sir, we are doing work on signal processing, niche area of signal processing, let's say. And the fundamental work which they are doing is operationalizing those research papers which our academics are coming out with. So that continuum is continuing. And this has to be synergized a little better. That is what our feeling in the army is. And we are willing to go the step. A lot was spoken about ROVs, remotely operated vehicles. Yes, that is the future area. We have weapon locating radars, which is an excellent example of the American ANTPQ, expensive ones, being replaced by DRDO, DRDO and the others who have got together an industry to make our indigenous radars. Akash weapon system already spoken about. And finally, I'd wind up by saying that the way ahead is very clear. The way ahead is in two parts, as we see it. One is involvement of the user in research and development. Because with a user perspective, and that's where I'd like to compliment today's organizers, is that they started the session with us, with the users. So the users' involvement at all these steps, we have a huge number of MTechs, officers who've done MTechs from the IITs. Many of our young people retire very soon, and the involvement of these people would give a lot of dividends. And the other is the Chinese model of reverse engineering. The Chinese have suddenly not had these research institutions. They've worked towards in the 70s and 80s, where the researchers in the US and in Europe, they did the research, did their work, and then they went back to the country in whatever form, and then they opened up those technologies. So that's, I think, the way forward, and I thank the organizers once again to allow me to be here, to privilege. Thank you very much. Thank you.
Extremely thankful, sir. First of all, I would acknowledge a serious blunder I made. He's Major General as Bhattacharya. I just made a big blunder. Thanks a lot, sir, for such a inspired talk of yours. I would now like to invite Air Commodore A.G. Sheer Sagar from the Indian Air Force to make his presentation.
Dr. Satish Kumar, CCRND, and all the esteemed members from the academia. It's it's encouraging, at the same time very I feel very awed to be in the presence of such eminent personalities who are in this gathering, encouraging in a way that their presence, your presence over here would definitely go a long way in solving some of the issues that we as the users in the Indian Air Force face, and as a continuous process look for solutions. So I would start with a small quote by Dr. APJ Abdul Kalam, and it's a very well-known quote, I suppose, from the Vision 2020 book of his, and this is what the driving factor for all of us, both from at all three levels, from the defense to the DRDO as well as to the academicians. As you all know, Indian Air Force operates cutting-edge technology defense equipment, most of which is imported as of now. Our dependence on imported equipment is close to about 70%, and this dependence continues throughout the life cycle of the equipment as of now. We do depend upon critical technologies, critical equipment, critical spares. All of these have to either get repaired, overhauled, imported all the time. We have had limited success in indigenous production. As you all know, we are having a continuous interface with the industries from our base repair depots, and so far what we have achieved is the low cost, high volume items like split pins and other small items that you can think of. These are already been indigenized, and we have moved towards having major aggregates indigenization. However, we still lack in critical technologies and critical components which we still need to go back to OEM for their repairs, maintenance or procurement. And therefore this gives, there is definitely a need to encourage R&D in the educational institute and industry to give us those kind of independent technologies. As we see, there are two distinct avenues for research and development. One is in a completely new technologies which the SA2RM had spoken about in the first session. These are the ones which are absolutely ab initio, new technologies on which the world is working on, and we also need to graduate into that. By and large, these have been already spelled out in the technology perspective and capability roadmap, which is the information available in the public domain, and SA2RM has elaborated in quite a bit of details as to what the DRDO is working on these areas. But there is a separately different kind of an area which we would like to, I would like to touch upon some of these areas, and that is to support the operations of the aircraft and other weapon systems already inducted into Indian Air Force. We have this equipment with us, but we do not have critical technologies to support this equipment. So there is an area, or there is an avenue for carrying out research and development into these areas which will support us in our operations and maintenance of this equipment. I would not spend, though I had planned to spend few moments on this, but these are the technologies for which enough has been said by SA2RM, and I would not dare to expand on any of these issues anymore. So directly going on to the avenues for R&D for the educational institutes. When I was looking at and was told to prepare for this presentation, and when we looked at some of the technologies that we are presently looking at, it was a very vast canvas that was that came up in front of me. And given the time frame of what we are told to present, I am only touching upon some of the critical technologies that we are looking for solutions, and this is by no way a comprehensive kind of a roadmap, but just an indicator. Okay, we prioritize these technologies based on primarily as the MOD's directions on reduction of import dependence. We are also wanting these technologies because of prohibitive cost of import of these technologies. Indigenous capability development as an independent driver is a requirement. There are some technology which are causing production holdups, or they cause our aircraft to remain on ground, and therefore we need help from the academia on that ground. And of course, there are many areas where we continue to, as was brought out by my previous speaker from the Army, that the OEMs are no longer supporting us into those equipment, and we find difficulties in maintaining that. So one of the first of the areas which I would like to touch upon is protective coatings on aero engine blades. You see, compressor and the rotor blades of the aero engines do tend to wear out while operating in harsh conditions that we have, as far as the humidity, the temperatures, the salt, as well as the dust environment, and they do erode over a period of time. Whenever we operate them for a longer duration and they come up for overhauls, they get rejected, or there is a degradation in the performance. What we have as a technology which is available with the foreign vendors is that there is a protective coating which is placed on the blades which prevent such erosion. So I've just said that we have looking at something like physical vapor deposition is one such technique, and there could be many other techniques which would prevent aero engine blades from deteriorating in their performance. Every manufacturer assigns a very limited life to aircraft and engines at the initial stages because of their very conservative estimates of utilization. But while during the when we continue to use them over a period of time, and because of various reasons, we do have to improve upon or extend life of this equipment. And there are techniques which allow us to check the integrity of the components and the aircraft airframes and other components, which are called as non-destructive evaluation techniques. And we do carry out in Air Force, we do carry out very regularly the life extension studies for detecting the extending the life of the equipment. And newer techniques in these areas, the technology in this area, if we could bring to the table, would allow us to carry out a better assessment of the life extension of this equipment. Another area where we would like help from the academic institutions is development of glues. A very huge types of glues are being used on for upgradable coatings to provide air labyrinth on aero engines. These have to be capable of withstanding very high temperatures and sustain them over a long period of time. They have to have high shear strength and have to be non-coagulating. These are some of the, just some of the properties which I am listing out over here as a thought process to provoke the thought process among the scientists and institutions, where we could look at such development of glues, where they would help us in increasing the life of the component or rejuvenating it in the process. Another technology which we would look for is the rubber compounds. Rubber compounds are used in the aviation industry in a very big way. We use them as seals, gasket hoses, and whole lot of things as we what we use them here. They need a huge number of properties to sustain them in the aviation industry. These are based on their applications. These are the various properties that they need to have, and we need to develop rubber compounds to suit the specific need based on these characteristics. So if we are in a position to take up the development of rubber compounds as a technology, it would help us in maintaining the equipment, it increasing its life, and reduce our import dependence. Nano composite coating is another area where our aircraft canopies, when they suffer the damage in the form of cuts and marks, they need to be rejuvenated. The nano composite coatings which have been tried out are, so one of the examples is that sol gel coating, which we are presently trying it out with ARCI Hyderabad, and there are many more such techniques where we can sort of rejuvenate the aircraft canopies, because this is a very, very high technology item where any rejection, we are still import dependent, and it is something which keeps recurring at a very regular interval in the Indian Air Force. This brings me to the basic factors of cockpit glasses and canopies. These are presently imported. There are various types of construction of canopies which are earlier used to be monolithic, but nowadays with the advancement of the technology, the laminate structures have been used, and transparency, frangibility, weight are some of the considerations which do not permit us. We do not have the technology to manufacture cockpit glass and canopies in India. We do need this technology to improve upon once again our own dependence on the OEM, and as well as have it as an self I would call it a capability to attain for future. Our BRDs carry out large number of reclamation processes. If a component cannot be reclaimed, then it has to be replaced. So if the rejected parts can be reused through reclamation process, now there are plenty of reclamation processes possible. They are like nitriding or metal depositions or many such examples which we are presently using, but I'm sure with your knowledge base, with your experience, you would be able to come up with many more such reclamation processes. And if these are given a boost, these can be thought about and can be explained across to us, we would be more than willing to take them on board for carrying out our reclamation processes. This was primarily intended for actually the some of the private industries which I thought would be participating in this conference. But all the same, these are some of the manufacturing or the processes in which we are expecting some kind of a research work and sort of improvement into the materials, the aviation bearings. Entire aviation bearings are not only in the aero engines but into many other moving components of the aircraft, and it's a very specialist kind of a technology. We do not have this with us. Precision machining, welding, a whole lot of aircraft tires. We had a major breakthrough recently in the past with aircraft tires, and we have been able to indigenize the aircraft tires of Su-30 and other aircraft, and there is a big boost being given into that. But this is another area where more research work is possible. Aircraft batteries, we're graduating from lead acid to the silver zinc to NiCad to lithium ion, and a whole lot of, there is a whole process which is going on of aircraft battery development. So cockpit displays, which already been talked about, and of course the simulators. My senior Army colleague had already spoken about simulators. We in the Indian Air Force also look forward to have fixed base full mission simulators and such kind of simulators in various aspects of training, which could be developed by either the industry or the academicians to help us in training our operators into these areas. How do we do this? We have something called as IAF Technology Board, which is in functioning for last about 3 years. It is under the chairmanship of Air Officer in Charge Maintenance at Air Headquarters for enhancing the capability of and undertaking such R&D work. It was thought of as a medium for exchange of technology related information, and we hope to create a data bank. We encourage the R&D type of projects through IAF Technology Board, which meets at once in 6 months for every year. And year on year, we take on projects which are funded by the Indian Air Force through R&D budget. And whenever we find that our budgets are not sufficient, we approach our big brother DRDO or others, and they have been very kind enough to have sponsored any one of our requests and accommodated them very well. And they do also provide the funds for undertaking such research projects. So this is one of the avenues, one of the places where the academic institutions can come forward into these areas which I have just mentioned. This list is by no means comprehensive. This is by no means limiting. It is as we probably interact more and more, the avenues for cooperation between the Indian Air Force and the academicians will improve, and more areas are possible for us to work on. I would just leave this address with you for the purpose of contacting us, and hope to get responses from the interested academic institutions on this issue. I am not in a position to give any specific projects at this stage, but as and when we interact, the requirements would emerge, and that's the way forward, that by more and more interactions, I would like to move forward on this issue. I take this opportunity to thank the Engineering Watch to have provided us a platform of direct interaction with the academicians, as well as act as a hand-holding process, and hope to get more response in this area. Thank you very much, and Jai Hind.
Thanks a lot, sir. From land to air, now to the high seas, I would now like to invite Rear Admiral P.J. Randachari for his presentation on the session.
Distinguished academicians, ladies and gentlemen, who are specialists in various fields, a very good morning to all of you. In the next 10 minutes or so, it shall be my endeavor to put across to you some of the areas of great interest to us. And as I try to do this, I would also like to highlight firstly the environment in which we operate. As you are all aware, a naval platform is a complex conglomerate of several equipment and systems, all unified together into a hull to perform certain roles for which she has been designed. This is one part of it. The second part of it is, of course, largely dependent on the kind of equipment, the kind of systems, the type of threats that are there, and the type of advances that the adversary has made. Taken together, it simply means that the kind of equipment, the systems and the ships that we have will have to be far more superior to start with, which of course is dependent on the extent of research and the technology that we have at our disposal. Now, coupled with this, just going to the next step, the systems are so integrated that they are strongly coupled. There is severe interaction between systems, and anything that is done to a particular system obviously affects the other. There is a great amount of energy balance that is there within the platform. So against this backdrop, therefore, there is a requirement to look at various areas, though apparently they are different fields. Again, there is some kind of an unison at various levels, whether it's in material technology or in any other niche area that we are looking at. And that becomes a force multiplier even as we look into it. Now, the platform, because by virtue of its roles, obviously has several conflicting parameters within it, and to start with, it would have been designed to optimize its performance against various parameters which are apparently in conflict, which can be anything from cost, which is a unit production cost, to true life cost, to technology, to technical risk, to type of signatures that we want, to the availability, reliability and maintainability aspects, to the kind of indigenous production that is possible, and so on. Now, at this point, I just like to highlight one important aspect. The Navy has been very fortunate to recognize this early, maybe in the 60s, and we started off indigenous production of ships. A modest beginning was made, and ships are being built indigenously today in the Navy, with several equipment also being indigenously built. Some of the weapon systems are also getting integrated, designed and manufactured indigenously. But then, as I said, depending on the threat levels, depending upon what the adversary has, depending upon the improvements in technology, the advances made in each of the fields, there is a requirement to revisit continuously and keep effecting improvements in all areas of interest to us. So against this backdrop, I just want to highlight some of the requirements for us. We would be interested in developing a package for dynamic simulation of propulsion systems. That's one area. There are various types of propulsion systems that we can have. A large number of them are there in various combinations. We would like to have something that models, simulates and understands the propulsion system in a complex, harsh environment such as the sea, where it is non-linear, it is uncertain, and therefore you need to account for all of these factors through mathematical models and find solutions which can help us in designing propulsion systems which have a higher performance indices, reliable under such conditions of operation, and of course they are able to have a longer life during the course of exploitation. Then we recognize also that great strides have been made world across in the area of electric propulsion, what is variously termed as integrated power systems, integrated full electric propulsion system, or simply the integrated electric propulsion system. So we need to have, we need to analyze, we need to have models, and we need to simulate the power systems that are necessary. Why is this important? If you recollect what the essay to RM said, we are looking at high energy weapons. Now, if you think about it, about high energy weapons, let us say like a rail gun operating from a ship, you need powers to the tune of about 20 megawatts and plus. Now, obviously, if we have a conventional system, this power gets locked when we are propelling at lower powers. So, to unleash this power, we need an integrated power system which makes itself available for such operations, and therefore electric propulsion becomes one of the important requirements. It also gives the flexibility. Now, having said it, then you need to look at, firstly you need to model and simulate the electric propulsion system as a whole, as an entity, and thereafter you have to convert that simulation and modeling into products which I will list out separately as to what we can do. Things like superconducting motors, permanent magnet motors, advanced induction motors, and so on naturally become products of interest because they fit into the ambit of things as we look at it. Then we need to have packages which can be used for modeling and simulation of ship motion. That is basically for combined maneuvering, station keeping and sea keeping. Again, it's in a complex environment. There will be 6 degrees of motion, of freedom, and therefore we need to have solutions for such operations. It may not converge, it may get into partial differential equations and so on. But the fact of the matter is that such requirements are there as part of research. Then we need to also model and simulate and understand various types of propulsors. The kind of propulsors that are in use today range from fixed pitch propellers, contour rotating propellers, controllable pitch propellers, all kinds of other propulsion systems, water jet propellers, or you just name it, they are in use. These will need to be understood and ushered as part of technology into the Navy for meeting various mission requirements. Similarly, we also need to get into areas of other auxiliaries and electric machinery for future combatants. This can have various paradigms. It can be from a simple thing such as variable capacity centrifugal pumps, canned motors, magnetic bearings, superconducting motors, etc. Each one of them has various advantages. I'm not getting into those aspects. Then we also need to create something called a propulsion system integration development environment, which is important because it effectively integrates all functions related to not just the propulsion system integration. It has multifarious fields in it. It has thermal engineering, it has material engineering, it has got metallurgical engineering, it has a whole lot of other aspects built into it, and therefore it's an important niche area for us to be looking into. Then we look at the next area, which is the air independent propulsion systems. We have various types of systems within that, but one that is of interest to us would be fuel cell technology. Great strides have been made within the country, but research is still going on. Some of them have been converted into prototypes. But if you look at other countries, German Navy for instance, it uses proton exchange membrane fuel cell. The membrane that is available there is proprietary to them. So similar such things are being developed within the country also. So we need to look at fuel cell technology as a viable option because it enhances the capabilities of a submarine, for instance. It enhances the dive endurance and so on. Then the next important area, which is common to all of us, whether it is in the Army, Navy or the Air Force, is the condition monitoring and fault diagnostic tools, which is an important area, which can range from simple handheld devices, starting from vibration to oils to signal processing techniques to acoustic, parametric, non-parametric, etc. And of course, we need to have something which is based on artificial intelligence, neural networks and such areas. So we need to have condition monitoring and fault diagnostic tools, either as a built-in system for the equipment or as handheld ones which can be used on board. Then we need to look at design of or infrared suppression systems. Then we have the heating, ventilation and air conditioning systems, what is commonly termed as the HVAC systems, which can be used on board. Then we need, depending on the acoustic signature that is required, we need to have tuned mass dampers to be developed for specific applications to take care of certain frequencies of interest. That is again an area of interest. And one of the areas which is very important, which has been highlighted by my armed forces colleagues earlier, is that we are interested in predicting the residual life of components of systems, which is an important area. The reasons for which have already been highlighted by the other two speakers. So we need to have methods. We may like to get into fracture mechanics, for instance, as a field, to find out what is the residual life of this component with so many millimeters of crack, and how is it going to propagate. We need to get into such areas. And we need to also look at damping materials for stealth. And we need to look at composite superstructures which are necessary for the lightweight, getting into composites and so on. Mounting systems is another area. Designing of composite propellers, composite pipes, and norms for mounting equipment on a raft, which obviously will have its own, it needs to be designed specifically so that the underwater radiated noise levels are minimum, and the raft with the equipment that is installed on it is able to absorb all of those. So a typical vibration problem, if you like it. And another important area is we need to design equipment for shock. If you imagine a 10-ton TNT exploding in the vicinity of the ship, the kind of shock waves that it is going to produce and the impact it is going to have on the equipment and on the ship's hull is something that you can visualize. So we need to design equipment for shock. We need to understand shock, and we need to design equipment for shock. Then you need to have vibroacoustic tiles, for instance, for submarines. You need to have radar absorbing paints. Then we need to have detection algorithms which are complex and which are based on, which are robust, stable, and which are required in sonars. Then we need to have high thickness epoxy coatings which for monitoring corrosion. Now if I just look at the cross section of some of the products that we might need, we need to have propulsion system components for, let's say, electric propulsion, which can be superconducting motors, advanced induction motors, converters as I mentioned, magnetic bearings, acoustic coatings, infrared signature suppression devices, shock and vibration mounts, tune mass dampers, handheld condition monitoring devices, high pressure water mesh system, firefighting systems basically. We need to have meteorological devices which can be used for underwater measurements without having to dock the ship. We need to get into VME hardware, which we can probably manufacture, design and manufacture. Then we need specialized steel as hull material and also weld consumables. We need to look at anti-fouling coatings which are environmentally safe. And we need to have automated systems, let's say for cable pulling and so on. Long life paint schemes and surface tolerant paint scheme for bilges. And we need to have radar transparent guardrail ropes with high strength. We need to have transportation solutions for various categories that exist on board. And we may look at, in the software area, we may like to have packages which can be in the area of propulsion system integration and dynamic simulation, for HVAC system, for shock analysis, for integrated full electric propulsion system analysis, for availability, reliability and maintainability studies of the platform and of individual equipment, for survivability and vulnerability studies, which is again important. And we need to have AIP systems which can be modeled and analyzed. And we also need to get into steganography, an area for communication, ship motion analysis, and other niche areas have already been covered in detail by the SA to RM, but I just highlight robotics and artificial intelligence, sensors, photonics, lasers, MEMS, direct energy weapons, material technology, stealth, particularly metametals, high energetics, explosives, antimatter, thorium technology, fusion technology, space technology, hypersonics, there is an understanding of nanomaterial science, nanomaterial, but how to convert that into nanotechnology as a product. One of the areas that he mentioned, which is of great interest to us, is to increase the operational life of an equipment which does not have a replacement. Is it possible for us to give a coating of some nanomaterial with certain properties which will enhance the properties of the parent material and thereby increase its life? These are areas which we can look into. And of course, biotechnical weapons, the IT and cyber technology that is well known to us. There are many things that can be done there with high computing powers that are available at our disposal. The unmanned vehicles, UAVs, of course, are a potential area for development which has been amply highlighted by the SA to RM. Then we have embedded computation for enhancing performance of weapons and sensor systems, including size reduction. And we need to look at more powerful and versatile decision-making systems which we have to be extremely active in a predictive sense and also within the limited time that is available for taking such decisions on board in the face of a threat. And of course, simulation studies for various other requirements. the requirements of training simulators have been highlighted. We need that in each of these areas whenever it is in the process of getting when it is in the process of getting converted into a product. It's better to go through a simulator route. It also helps in training of various personnel who are going to be looking after this. And similar such requirements, of course, microelectronic mechanical systems is another area that we may like to look at. These are very few areas that are highlighted. There are many others. Because of the limited time available, it is not possible for me to get down into details of each one of them. We'll certainly do that in case we have an opportunity to discuss this in greater detail later on. But at this point in time, I am very confident that with the active involvement of several academicians in this country from various institutes, and the specific requirements that we highlight from time to time, and with the greater involvement of DRDO as they have been doing all along in also getting the academic institutions on board, and with the Engineering Watch acting as the right launch pad for this great activity, I am sure that we will make progress in all of these niche areas in times to come. On behalf of the Chief of the Naval Staff, I would like to thank the Engineering Watch for giving us this opportunity to put across some of the points that we have in our mind, and I'm sure that with greater interaction we will be able to move into converting these ideas into products of interest to us. Thank you very much.
Thanks a lot, sir, for such an elaborate presentation. We would be able to open up for certain questions so that let the conversation go both hands. But before that, I would like to invite Mr. Raymond Pinto, scientist, Radar Division at Navi Mumbai from Department of Electronics and Information Communications Technology, to make his presentation on this session. Mr. Raymond Pinto. Okay, he could not. We can open up the house for questions for say 10 minutes or so, 10-15 minutes. So the mics are there. You can use the mics there. The mics are there on each table. You can use. Yeah. You can just push it and we can just have it. Sir, please.
Yes, hello.
Yeah, I'll cover one point with the permission of the chair. I was just discussing with the CC R&D with all his experience, and he said that I do have an interesting idea. You see, we have spoken as users about huge amount of technologies. But what does a person from a director or a vice chancellor of a private institute do who has near zero R&D funds? Now, as all of us know, and the CC R&D would know, that as we go along and see institutions like BARC, TIFR, DRDO labs, which are doing amazing kind of work, at least when I went around them in my service career, I did not find a single person over there from the IITs. Especially today, I don't find anybody from the IITs, hardly one or two from the NITs. So what does it indicate? It indicates that all this cutting edge work is being done not by the top end universities, the top 20, boys from there, boys and girls from there, but is being done by smaller universities, and many of them are private institutions with zero research funding. So just imagine if they were to have some kind of a training in their academic curriculum, especially during the MTech, the last year of BTech and PhDs, those who are doing PhD courses. So the idea I have is this. Now, the DRDO is a very open organization, though it does a lot of secret work, but they're very open, environment friendly. If one interacts with them, they will be able to offer technologies. Let's say there is an institute from Punjab. I met some gentleman director from there. Let's say this Punjab University, a small college somewhere, it identifies one particular small little technology in rubber or plastic or maybe decision sciences, and then in a 3-year cycle, it encourages their students to write papers on it. First, they study about it and write papers on it, and slowly develop in all these 3 domains, the BTech, the MTechs and the research. They take up this. So slowly what you have done is you made your institute into, after 3 to 5 years, into a specialist kind of a domain, academic domain on this particular technology, and the DRDO, I'm sure, would love to absorb this kind of technology and give a motivation to you, maybe funding later on. And for this, the kind of research papers can start small, but then they have to be of a quality of which can be accepted by publishers such as Emerald, EBSCO or Elsevier or something. So this was my basic idea, where the private institutions, which many of you represent over here, can do to the national cause in the humble way with hardly any funding. Thank you.
That's sorry interrupting. That's what exactly I had a point. Later I requested him for point. We are a very small charitable institute. We have very big universities around, private universities around. But our basic motto of the university is education is a service to society, not a business. But most of the thing you know, the scenario you read every day, most of the business houses have come. Nothing against them. But here also you find all premier institutes. You know, how do the, if hockey of villages had not gone to cities, we would have been still world champions. We are only considered a few premier institutes. As they said, they'll do everything and go abroad. And we tried our best to get listed with your department. I think we never got a response. I tried to use my connections, having been DGCO earlier. But again, okay, that's why I told Raghav I'll request 5 minutes. Luckily I got chance, and I belong to the same organization with Jan Bhattacharya. So I think I'll later on interact with you. These small institutes must get a chance because we got real brains. If my student from a village can top MSCIT in university, but only for lack of funds and for lack of exposure, nobody visits us. We invite IBM, Infosys, they go to a particular city where there's air connectivity or people can lodge them in big hotels, but they don't dare 40 kilometers away into the village. So I agree with him. I think we can explore this, giving some chance who are not into business or something, but into charity, into really the service of the nation. Thank you very much.
I will also second the thought of
I am head of R&D.
thought of General Dillo. Actually, I'm working there as a R&D head. Actually, we wrote a grant to DRDO. They were very generous to fund us for some amount, but abruptly DRD Gwalior stopped the grant without giving any reasons. So the progress of the grant was sent on appropriate time, but basically they stopped giving no reason. They said to write a bigger grant because it's a very interesting subject on arsenic and pesticide contamination in groundwaters. They said you would write a larger project. So I wrote to LSRB actually, but nothing happened actually, no response from them. It's been like 1 year, more than 1 year. And they thoroughly appreciated, and we are basically, I lived in America for 14 years. I quit everything. I returned back to India just to serve this organization, which is in a rural area. And the type of students we get is all from rural background. So basically, if I was writing, Indian Institute of Science was there, Jadavpur University was there, Rocket Motor, IIT Chennai was there. It's a very humble request from us that, well, if we can return back to our motherland after so many years to serve our country, funding should be given to rural areas as well, universities, small colleges as well, because we are doing some good research on that, which is being appreciated. Thank you.
Which college you belong to?
Sant Baba Park Singh Educational Complex.
Algetic, I am director of that place. Having retired as DGCO as Lieutenant General from Army, I have gone back to my village. If I can become a Lieutenant General from a village, possibly you get a small student from a village area who can become a scientist like you. So that's the thing.
So probably you require a geographical inclusion in the R&D space.
Hello, can I speak now?
Hello.
This side, yeah, please.
Okay, then let them finish.
Yeah.
Yeah. You see, I am Dr. Vajpayee, the Chancellor of Beltech University. We are also in the suburb area. Actually, the knowledge is not the institution, intensive. It is, the pupil intensive. Could be village or could be anywhere. At the core level, we are doing wonderful job. We are earning more than 25 crore rupees in a year. And you see, we have got more than 2.75, about 3 crore rupees project from the DRDO. And we are delivering, is not the open-ended, is, giving the product. We are the people, who are, working with the GATEC and have developed fantastic facility for 25,000 RPM, measurements. And this involves not only what is called the mechanical design stability or condition monitoring, as people are talking about. What it involves also, taking and testing other kind of polymer fluids which goes into the bearings, which goes into the lubricant. And for that, we are involving other defense laboratories. We invited them, for example, the Kanpur Defense Materials Laboratory. They came forward. They are working with us. and a lot of facilities we are doing with that. So condition monitoring, lubricant testing, high speed testing, wear and tear, and all that we do. We are all doing, so much with the MBDA missile group, they have given us the product. Our students go and we work with them. We also work with other universities like Branch, many areas like non-destructive testing, the forecasting, designing. We have got the best CATIA design facility. We can make the component, we can do the heat treacle, what we do. We work also with the Taiwan. Taiwan, there is one Gita program with the government of India. We've got more than about almost 2 crore projects, and we work with them. And these projects are so nice. Actually, we work on like helicopter. We work for the unmanned aerial vehicles. We work for developing varieties of materials on that. And we have also got a very good building people. Not like aluminum, you cannot make India. I was also one of the director of CSI Laboratories, CSIO Chandigarh. This head-up display for the light combat aircraft is mine. Intermediate jet trainer, me, Yogesh Kumar, and Manti Saab was, and the Bobeja also joined. We did a wonderful job in no time.
If I have the list, then I'll circulate to all the faculty member, and then I can, because all number of research have been done already.
Thank you, sir.
One question related to same thing, as Air Force person has given the contact point, I would request Army and Navy also.
10th of the today's price, and its capacity will be 10 times. So
I think lunchtime you can certainly interface with sir. Yeah.
Definitely.
And last 2 years, with the joining of Monsawai, he has seen the war. He gave me a few ideas. Yes, medical, it's a University of Biotechnology Management Sciences. So biotechnology, bioengineering, so normally this gets the low priority. Anyway, we get in touch with the DRDO.
What we get, we hardly import any instrument. Mostly Indian industries which are manufacturing the instrumentation, which are included in the private institution. About 4,000 students in our campus, okay, and they get placement throughout the country. Even the Infosys, we are sending our students training, and many students go to the defense also. They are trained with the indigenous instrumentation or SAM, which comes imported, certainly. Even the XRD machine which comes from Philips, there are about 1,000 installations throughout the country. Perhaps maybe VIT Vellore might be having a XRD unit. We don't have a XRD unit in Rajasthan. I'm from Jaipur. It's about 13 kilometers from the city center. In University of Rajasthan.
What is your problem of importing? Because you get a DSIR, again exemption in excise, you cost the same.
Okay. The trained manpower with joint defense, okay, they should be trained with the indigenous component. Like I'm an expert of thin film technology. I work with the nanotechnology. I developed membrane with the carbon nanotube embedded polymers. Okay, but most of the investigations I use the imported instruments, which are not there in the private institution. So if I continue, zero. Even when I say my MTech student, my colleague is there in MNIT, they charge 1,500 rupees for one is SAM. So that is the drawback which is coming up. Most of the instruments which are expensive, which are installed in the government organization like in DRDO, okay, and the private institutions, although they are paying their dividend to the government in some way or other, sending manpower, okay, giving to the society.
In the armed forces, the present policy is that we don't want anything free. For every development, we are ready to pay, because that is what the need of the hour is. So our projects are published on the web page. The universities or colleges are free to come and interact with us, participate in the process.
The board we accept, there is a website of that board, we accept the proposals on this board of the nature what you have expressed. And we have a process that once you apply for some project, then there is a panel of experts. Those experts will go through your proposal. They will see that what is the value in that project proposal, and that board, once it clears, then the project is awarded. It's a very simple process. There is no complexity.
Hello, this is
Professor Murugesan from B.S. Abdurrahman University, a Muslim minority private, send the proposals to the respective defense force. Thank you.
Thank you, sir. Any more, sir, please? Please, sir.
I fully agree with Major General Bhattacharya. Institutions can take up some studies, initial studies on certain technologies which are highlighted here. And in this direction, I have one university based in Chennai. I am Dr. Ilavayagan, Director of Research. I was formerly an outstanding scientist and Director of Life Sciences in DRDO. What I have done is I have initiated projects, some 10 projects, identified some, many of these on.
First of all, I would like to congratulate my friends from Army, Air Force, Navy for making the wonderful presentation in their area of work, and they very clearly brought out their requirement where you can interact with them in their area for the future research, maintenance, repair and overhaul. So that is one thing. It has come out very clearly. And probably they have the website. You can reach their website, you can interact with them and then discuss with them. Secondly, the different type of the queries has come. Before that, I would like to tell you that now DRDO, we have basically 3 research boards, four research boards, and the extramural research, all research panels, research boards and extramural research, it has come under one umbrella. So now there won't be any disconnect in the future. So that I want to assure you very clearly. And we want to reach each and everybody in the country, all the directions, north, south, east, west. There is no discrimination. For that, basically now, earlier, mostly we used to go to the prestigious institute of the country, IITs and NITs. Now we want to draw up a program. I have taken up your all questions, what Professor Bajpayee, then General Dillo, there was a query from IIT Roorkee, then Dr. Sandeep Singh, Dr. Lamba, and Bharat Electronics, and many other friends, those who have raised a number of questions. So to see that now we also feel that there is a requirement that we have so many institutes all over the country, private universities, private research institutes. So we should give due respect and due diligence we should do. There are so many good institutes. We cannot say that good institutes are not there, and good quality product students are also coming from many private engineering colleges. There is no doubt about it. So we acknowledge that, and I am very happy that it's a very good participation from the various parts of the country, from the northeast. I was very happy. One of my gentlemen, he is there. So he was discussing that we have to reach them. And in fact, General Bhattacharya, he gave me an idea that we should have some outreach program. So it's a very good idea. We take it, and we will see that how to create a synergy between the R&D and the academic institutes and private industries. So certainly we are going to draw up a program, and we are going to create a very vibrant website of all the research board. We have the research board on the armament technology, ARMREF. We have a board on the naval science and research board. Then we have the ARDB, Aeronautical Research and Development Board. Then we have the Life Science Board, Life Science Research Board, where you brought out professor from Himachal, Solan. He brought out that earlier Professor Dr. Sallamurthy was interacting with you. So that's a very good board. Number of the life science related issues from all over the country has been number of projects we gave. And we have the extramural research. So there is a lot of scope. In addition to that, we have the boards in the services. In fact, now I am going one more step ahead. In these research boards, we would like to invite our friends from the Army, Air Force, Navy. We want to create a very close coupling, close association, so that we can see that the requirement. Because I agree with Air Commodore, there may be a funding limitations in Air Force, Army, Navy, or it may not be. If you have, then there is no problem. But in these research boards, we can certainly would like to have the participation, though we have a member from the services, but we want to make it, more vibrant. And certainly the project of your interest also, you can list out and you can give through these boards. You are most welcome, and you only have to drive that. You see that your requirements should be met. Whatever you want, in addition to your board, that you do through the research boards also, we can work together. I assure, and we will have a meeting. Together we can see that who are the active dynamic members from services. We can put in those boards, and we can see that the more projects we can do with the academic institutes. So this is what I thought that it will address your concern. And certainly you will get the projects. There is no doubt. I am assuring that. So that and teams will make. Those teams will visit to the various institutes, various universities. But one concern which I have, that institute and university have of some reasonably good quality. That I would like to share with you. We had some bitter experience also in the past. Please don't mind by saying that. Some of the private universities we gave the project. The principal investigators, they closed the project. In fact, we are finding it difficulty to recover the money, because this is a public money what we are spending, and it is being audited. So those things also I want to share my concern with you. So it is not that we can go and give the project just like that. So we have to have a commitment from both the sides. So we value, we respect the universities. They are doing a very good job, but at the same time we have to be responsible for that. So those care we have to take. Otherwise, absolutely there is no concern, and all the issues what has been brought out by all of you today, these issues I have noted down, all the concern. This I am going to discuss with the Chief of DRDO, and we will come out with a roadmap that how we can interact with the universities in the country other than the IITs, ISCs and the NITs, where we have given lot of projects, lot of, in fact, we are having a problem now. With these institutes, they don't have time. They have, naturally they have a limited capacity. IITs also, they have a limited capacity. You brought out also, then Dillo brought out also. So we are looking for a good quality manpower in the country. And to see that the projects where there is a delay, where there is a problem, and jointly services as well as DRDO, jointly we want to see that our project should be done in the time. And for that you can really have a great value if the some of the technology readiness level up to technology readiness TRL level to up to 3 or 4, if it can be done in the university, and the university can draw a program, or we can have a regionally, you can 3-4 universities or engineering, you can put your effort together. We need not to work individually. That can bring out a greater value. You have make an umbrella, work under one umbrella, and then tell DRDO and services that we can do this. If somebody is good in maintenance repair, certainly we can support, all of us can support for the maintenance, because that is also a key area. We ultimately this research, I am very plain in saying that the research what we are doing, the effort what we are putting, it is for my all these friends. Ultimately it has to go to them. If they are happy with us, our purpose is served. So we have to put our effort in that direction. So if we come out with a plan, program, and somebody can take the leadership. Suppose you go, many people are there from north. If they can draw a program, somebody can take the leadership. Okay, Himachal, I take the leadership. You take the leadership, and say that all these colleges they can do this. Then DRDO can make a program, come to you. Okay, you do this. This is the money. You deliver this to the DRDO and to the forces. Similarly, in the south, Dr. Sundarajan is there from DRDO itself. He is a distinguished scientist of DRDO. Many of you can make a bridge between the academic institute and DRDO and services. Similarly, Professor Vajpayee is there. He in fact developed CSIO. We have lot of regard and respect for him. I was the director of TBRL at that time also. With CSIO we did lot of work. So we can make that kind of an umbrella instead of going into the pockets and then working. It will not serve the purpose. So we should see that how we can make R&D effective for the defense. That should be our aim. Like many people we talk of DARPA and US programs. They do like that only. They don't go and spend the money in the pockets. Basically, they have a multi-university programs where the universities they come together and then they work. They see the core competence of each other and then see that how they can fit into the total program. So that kind of approach, if we can take and if we can work, then certainly we can succeed. In the mode I was discussing with Dr. Agarwal, he is from Bangalore. So he has number of scientists from ESSC with him. So they are all experienced. Those who have the hands-on experience. We are looking for such kind of people. We do not have. We have the scarcity of the people today. So if you can bring out that what we can do, what you can do, certainly we are for that. Absolutely there is no problem. And the methodology, procedures, that you leave it to me, I will make it simple. So that you people need not to struggle to get the money, but you have to deliver. That also is this one.
I think that calls for a big clapping, big applause. Thanks a lot, sir. With this, we conclude this session, and before we move on to the next, I request